This is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate. Please don't share personal information during the class for your own security reasons. All right, so here's what I want to know today. Go ahead, type on the board. What is one positive action that you will do today to either improve your day, improve someone else's day, improve the world? Go ahead, tell me on the whiteboard one positive thing you're going to do today. Let's have it. Again, let's work quickly, participate together. That way we can end our class on time. We don't have to go overtime. Get your answers up there. Looking good. Make sure I'm getting your green checks as well once you have your ticket open. Again, those links and password are being pasted in the chat box by Mr. Alch. Looking good. I see Efren on the board. I see Ireland in the chat box. Let's get lots of participation. Awesome. I see Bradley on the board. Thank you. Let's go ahead and get some answers. Amanda, Tony, Ashton on the whiteboard. And Brianna, let's get your answers up on the whiteboard. Damien and Donnie. Awesome. I see Ethan working on the board. Let's get an answer from Isaiah and Elias. Oh no, Ethan. You can still do positive things even when you're grounded, right? Maybe say something nice to someone even though you're grounded, right? Or you can make sure that you do all of the stuff you need to do today. Yeah, try to get ungrounded, right? I see Israel typing. Let's get some more answers on the board. Jade, Jackie, Jasmine, Josiah, Jessica, want to hear from you. Oh, done with state testing. I know, Israel, we've missed you. Let's get some more answers up there. Yolese, Whitney, Valeska, TJ. Yeah, state testing. Did you have an entire week of it? I know some students have like half a week, some students have one day. But did you have to go every single day? Oh no, you didn't. That's good. That's good. 3 days. Okay. Yeah, so you had 3 longer days as opposed to 5 short days, right? Yeah, yeah. Some student. Oh yeah, 2 exams per day as opposed to just one per day. Yeah, that's rough. That's rough. Yeah, I have state testing next week. Oh, that reminds me, I need to make an announcement for tomorrow's PowerPoint since I will be out next week for live sessions. So we'll probably have some recordings going on next week, and then Mr. Alt will probably be taking care of the support sessions. So yeah, cool. All right, see Jackie on the board, Donnie on the board. I see Shoshana typing. Yeah, thank you, Caleb. All right, let's see here. Yes, don't forget your state testing. Absolutely. All right, yeah, let's go ahead and go over these answers. So, not sure, maybe finishing your duties at home. Um, uh, we do have an attendance ticket. Mr. Alch is putting it in there every once in a while, so just wait for it to load in there. Um, yeah, so it kind of depends. So some students have science, some students have SBAC, which is English and math, and I think some students have both, or it might be, yeah, I think actually might, yeah, it depends on what grade you're in. If you're not sure, Efren, you can always email me and I can look it up for you too. I'll get your ID and I can look it up, but obviously after class. Cool. All right. Ethan, you said you're grounded, right? We can still do positive things though, even when we're grounded. Sometimes even better to do positive things then so that we get ungrounded. Oh, you know it's science. Gotcha, Efren. Okay, yeah, so it sounds like just one day for you. If you only have to do science, science is only a single day. Um, Let's see here, Amanda, work out and do your chores. Jackie, you're going to get all your chores done, finish any missing assignments. Excellent. Donovan, get your homework homework on top of homework. Yeah, it's definitely a busy time of the quarter, right? And then catch up on some more classwork. All right, Bradley. Well, that sounds good, right? So definitely sounds like those things will also help us not be stressed out because we'll be getting our stuff done, getting on top of our work. Love it. All right, everyone, let's go ahead. Get your ticket open again. I do need green checks all around. Let me know if we're having issues with that. Um, yeah, I think it's 11th grade does the full testing roster, and then 12th grade just has science, I think. But don't take my word for that. I haven't proctored yet this so I'll know more after I proctor this upcoming week. All right. I have 18 green checks letting me know you've got your tickets open. Again, those links and passwords will be in the chat box. Perfect. All right, there we go. Let me know if you're having any issues opening that. As always, we are officially on day 15 out of 45 of quarter number 4. I don't know if this means anything to you guys, but this means we actually are 1/3 of the way through the quarter. So believe it or not, you have already finished 1/3 of the quarter. There's only 2/3 left. Guys, there's only about 6 weeks left of the quarter. It's going to go by crazy fast, which I'm thankful for. I'm sure you guys are too. So today we're going to talk a little bit more in depth about atomic number and atomic mass. Efren, you won a tournament in Hayward and you sunburned your nose. Oh no! It's peeling off. Oh, that's uncomfortable. I don't get sunburned very often. I've gotten sunburned twice in my life. There we go. All right, so today we'll be working on the 4B quiz. Yeah, Miss Ale, Mr. Alch is sending it out periodically, so just hold on a moment. He'll send it out again in a few moments because we have a bunch of people joining us, so he wants to make sure that we're catching as many people as possible. All right, so we are talking about atoms for Unit 4, right? Yesterday we took a look at kind of the broad characteristics of atoms. So today we're going to look in super close detail about atomic mass and atomic number, so 2 really important terms for today. And then remember tomorrow, or I think Monday, we'll be talking a little bit more about radioactivity. Okay, so here we go. Let's do a really quick review. So remember that atoms have 3 parts: protons, neutrons, and electrons. Remember, protons, that beginning sound is pro, and that tells you, are they positive, neutral, or negative? Tell me in the chat box. Are protons positive, negative, or neutral? Think about this prefix pro. What kind of charge do they have? Efren, arrow, awesome. Yes, exactly. So protons, right? Protons have a positive charge, and they are also going to be in our nucleus of our atom, and they are in charge of the identity of the atom. Remember, you can change everything else in the atom, and it's not going to change its identity unless you change the actual protons. So 6 protons will always be carbon, no matter what else is going on. 8 protons will always be oxygen, regardless of what else is going on in the atom. And remember, protons have mass, right? They actually weigh something, so we count them in when we're talking about the mass of the atom. Awesome. So neutrons, yes, neutrons. What do we know? Neutrons sounds like the word what? Tell me in the chat box. Neutrons, the beginning of neutrons sounds like what word? Okay, yeah, so Shoshana, if you can't make it to class tomorrow because of state testing, just email me and I'll make sure that you're taken care of, okay? Neutron sounds like the word neutral. Neutral. Smiley faces if that makes sense. So neutron, you should think of neutral. And remember, the word neutral means what kind of charge? +1, 0, or -1. Neutral, what kind of charge should you think of? Yeah, you should think of 0. Neutral means no charge. Okay, so neutrons have no charge. Again, they are found in the nucleus, and remember, all of our mass particles and particles with a big amount of mass are in the nucleus. So neutrons also have mass, and remember, because they're neutral, they're really good at stabilizing our nucleus, right? Remember, without those neutrons, protons would repel each other, and then our nucleus would fall apart, and then the universe would not exist as we know it. Okay. Yeah, Efren, make sure you email me, okay? I won't remember that, so you'll need to make sure that you email me, okay? About tomorrow if you have testing. Yep, thank you. And lastly, right, electrons, remember this idea that electrons sound like electricity. Getting shocked by electricity is a bad thing. So these have a negative charge. Remember, they're on the outside of our atom, and so just like the hands are on the outside of our body, which is why you can use your hands to hold hands with someone, electrons are on the outside of the atom, and they're really good at holding hands, all right, with other atoms. So that these are involved in bonding. Electrons allow us to bond 2 different atoms together to make something with unique properties, and they have almost no mass. Remember, if you think about the nucleus, it's kind of like a planet with our protons and our neutrons that are super massive. Electrons are so tiny that they're just kind of like a speck of dust in outer space around that atom. Give me a smiley face, everyone, if this is making sense, right? This is all the stuff that we learned from yesterday. Quick review, because this is going to help us make sure that we are on top of what we're going over today. Perfect. Okay, so here's our mind map for today. So we're going to start off talking really in depth about atomic number. And remember, atomic number tells us both the number of protons as well as the identity of the element. Okay, so the nature of an element is determined again by the number of protons. Protons equals identity. And the atomic number tells you the number of protons. So if you think about this, right, atomic number equals number of protons, which equals identity of the atom. Okay, so those things are all kind of synonymous with each other. Thumbs up if that makes sense. Those three things are all kind of synonymous with each other. Excellent. Okay, so even if an element exists in a different form, right? So for example, carbon can exist as gaseous carbon. It can exist as graphite. Where do we find graphite? I don't think I have one of these in my, oh, I do. Where do we find graphite? Tell me in the chat box. Yeah, you find graphite in pencils. So the lead for pencils is not actually lead because lead is toxic to humans. So instead, it's actually made up of graphite. So graphite is actually a form of carbon, and diamonds are also a form of carbon. And think about coal is a form of carbon. So there are many different ways that carbon can kind of show up and exist in our planet. But no matter what, if you look at their atoms still always have the same number of protons. They still always have 6 protons. Okay, so all of these things are made up of the same type of atom. Remember elements? Remember, elements are a bunch of the same type of atom. So elements we can't break down into anything simpler. So the element carbon, even if you have a bunch of carbon things and you keep on trying to break them down simpler and simpler, it's still just going to be carbon. Okay, this is number 1 in your ticket. Give me a green check when you have it saved. You have 30 seconds to fill in the blank with the word simpler as you see it right here. Green checks, everyone. Yes, I forgot. All right, need a few more green checks. Evelina, Amir, Tony, Bree, Chanel, Damien, Donnie, Dree, Dylan, Edwin, Jackie, Josiah, Jessica, Kyler, Letty, Matt, Blossom, TJ, Whitney. Remember, everyone, the more that you participate, the faster we can get through class, right? Part of the reason we keep on going over time is because I'm not getting responses fast enough. So please make sure you're responding. Please make sure you're on top of your work so that you're not slowing the rest of your classmates down. Excellent. All right, let's go ahead and move on. All right, so I figured this would be understandable now. So someone said, have you ever been cutting a piece of paper with scissors and worried that you might cut an atom in half and destroy the world? Then someone replied, paper does not have atoms. All right, so let's go ahead and break down what's wrong with this. First off, can we break down paper into something that's chemically different than paper just by cutting it? Tell me in the chat box, can we break down paper into something chemically different than paper? No, right? So it's very unlikely, right, that we'd be able to cut an atom in half, right, with just scissors, right? That's just ridiculous. Okay, so we're not going to destroy the world. There are ways, right, if you think about nuclear physics, where you can split an atom, and that does cause a lot of energy, but that requires like insane amounts of technology, not just cutting with scissors, right? And this one right here, what's wrong with this? Paper does not have atoms. Does paper not have atoms? Tell me in the chat box. It does, yeah. Remember, anything around you is made up of atoms, right? When we think about matter, yeah, everything around us that has mass is made up of atoms. Exactly. So at this point, you should definitely be able to see something like this and realize that they don't know what they're talking about. Okay? All right, cool. So again, different number of protons gives you a totally different element. And the question is, why is this important? Okay? So what I want you to take a look at here is hydrogen and helium. Hydrogen and helium are the 2 smallest atoms on the periodic table. Okay? They are teeny tiny atoms. Yeah, it might depend on what kind of atom, right, Efren? And to the amount that we destabilize it, right? Okay, so hydrogen and helium, they're the 2 tiniest atoms on the periodic table. Hydrogen has 1 proton, and helium has 2 protons, okay? But what I want you guys to go ahead and see is I'm going to go ahead and show you a video, and I want you to take a look at the difference between hydrogen and helium, even though they only have a single protons difference, Let's go ahead and take a look at this video. Green checks when you finish watching it.
Okay, so I have 2 balloons here. One's helium, one is hydrogen. Helium should not react, and the balloon will just pop. Hydrogen, on the other hand, will react with oxygen. Does not react. The balloon just pops.
So we have two balloons, right? There's the blue balloon, which is filled with helium, and the red balloon, which is filled with hydrogen. What do you notice about both of the balloons first off? Okay, tell me in the chat box, what do you notice about both of the balloons in the first place? One's filled with hydrogen and one's filled with helium, but they're both doing what at the beginning of the video? Tell me in the chat box. From Ireland, I see Efren typing, Dorian typing, Amanda typing. What are they both doing? Well, at the beginning, right? Yeah, so at the end, they're both popping, right? But at the beginning, before they're even popping, they're both filled with these gases and they're both doing what? Right? Because this is different than like when I just blow up a balloon with my breath, right? When I blow up my balloon with just breathing into it, that has a different result than if I actually fill it up with helium or hydrogen. Yeah, so they're both floating. Smiley faces if you guys see that. I feel like we didn't get a lot of response there, so I just want to make sure you guys recognize they're both floating, okay? Yeah, when you fill up a balloon just by blowing it up with your breath, does it float? Tell me in the chat box. If you just blow up a balloon using your lungs, does it float? No, exactly. So it's important to recognize that both of these are good gases for floating, right? They're both very non-dense because they're very tiny atoms. They're not super dense, and therefore they can actually float in the atmosphere around us, which is mostly nitrogen and oxygen, which are more dense. So that means that since these are less dense, they can float. So that's important to note. They both can float. Yeah, exactly. Parties would not be as fun if you didn't have floating balloons. Now, that being said, the blue balloon, the helium balloon, what happened when he tried to light it on fire? Tell me in the chat box. The first balloon, the helium balloon, what happened? What did we see happen? Let's get some participation in the chat box. I see Arrow typing, Ireland typing. Yeah, it just popped, right? It was just a simple pop. Nothing crazy happened there, right? What about with the red balloon filled with hydrogen? What happened when he tried to light the red one on fire? What happened then? That one was a cooler reaction. Awesome. I see Ireland typing, or Ireland's got an answer. Dorian typing, Arrow typing. Yeah, so it didn't just pop, right? So the balloon popped, but then inside what happened, right? We saw something cool happen for the red balloon. Come on, guys. I need you in the chat box. Let's focus. Let's get this done. Yeah, it exploded and went boom, and you saw fire, right? It was flammable. Did you guys see how like the shape of the balloon where there was the gas actually lit on fire? Okay, good. So that's really important to notice. So here's the thing. We know that hydrogen and helium are both really good at making things float. So how many of you, though, have ever heard of the Hindenburg disaster? There's a picture of it right here. Okay, how many of you have ever heard that or seen this? So the Hindenburg disaster from many, many years ago was when we first started using airships, okay? And airships, right, at one point we tried to fill them with hydrogen, okay? But the problem is we just saw hydrogen, even though it's one proton different from helium, is actually very flammable. And that's a big problem because you'll notice that when this had its accident, it went up in flames. Now, on the other hand, helium, we just saw, is not flammable, which is important because helium is often around flames when we're at birthday parties. Yes, very, very sad, right? So, but think about this. If you had children's balloons filled with helium, okay, or with hydrogen at a birthday party, and there are candles and they're blowing out candles and things are going, that could be a very dangerous situation. So a single proton's difference, right? One proton made hydrogen, which is very flammable, has a totally different identity than helium with its two protons, which is non-flammable. So that's why nowadays we want to use helium to help us float as opposed to hydrogen. Give me a smiley face if that makes sense. Okay, yeah, no problem, Efren. If you want to see the video again, I put it in the chat box. So there's the direct link to it. Excellent. All right, so a single proton makes a really big difference. Let's keep that in mind. So again, hydrogen and helium, very tiny, but they are very different from each other. Awesome. Okay, so the next thing that we need to talk about is atomic mass. What's another word that we often think about when we think about mass? Tell me in the chat box. It starts with a W, right? Oftentimes I say mass is similar to what on our Earth? Yes, mass is similar to weight. So a lot of times I might say weighing or mass, and in this case I mean them as synonyms, right? But just keep in mind that we talked about this last quarter where weight and mass aren't actually identical to each other, right? Mass is actually the amount of stuff that you're made up of, whereas weight is the amount of stuff plus gravity. Okay, so this means that on Earth, right, you have the same amount of mass as you do on the moon because you're always made up of the same amount of stuff. So your mass stays exactly the same. But on Earth, your weight can change compared to on the moon, right? Because gravity changes. Let's think about that. On the moon, is it easier or harder to jump? Tell me in the chat box, is it easier or harder to jump on the moon? Right? It's much easier, right? Because you weigh less because there's less gravity, right? So the Earth has more gravity, and so you have more weight. Whereas on the moon, we have less gravity and therefore less weight. But on both of them, you still have the same mass because you're still made up of the same amount of stuff. Okay? Amount of stuff. So again, I know I'm using them as synonyms, right? But I want to remind you that they technically aren't synonyms if I ever say it as weight versus mass. Okay, one more time, give me a smiley face if that makes sense. Let's go to the moon as a field trip. That would be fun. Not quite feasible yet. Awesome. All right, everyone. Okay, so atomic mass, remember, includes the massive parts of the atom, which we just discussed at the start of class. The only things that really have real mass are the protons and neutrons. They each weigh 1 atomic mass unit, okay, 1 AMU. Remember, we're ignoring electrons. I mean, I feel like the magic school bus, they probably beat us to moon. All right, so remember, when we talk about atomic mass, we're actually ignoring electrons because electrons are so teeny tiny, right? They're a speck compared to the protons and neutrons. They have almost no mass. They have about 0 AMUs. I know, I love Magic School Bus. I watched the newest season too. It's always good information, right? I always find really good things for my classes too. So atomic mass, you can see the equation here, right? It equals number of protons plus number of neutrons. Thumbs up if we understand that. Number of protons plus number of neutrons. Again, we ignore electrons because electrons are too tiny. Electrons are just too tiny. Cool. All right, so if you take a look here, right, carbon, okay, if you see here, carbon has 6 protons, 1, 2, 3, 4, 5, 6. 6 neutrons, 1, 2, 3, 4, 5, 6. So 6 plus 6 gives you an atomic mass of 12. So it weighs 12 AMUs. Okay, so that should make sense, right? Again, we ignore all the electrons. Electrons are too tiny. They don't count, okay? They weigh almost 0. Awesome. Now, that being said, okay, the thing is that sometimes you can actually change the mass of an atom without changing its identity. And this is what's called an isotope. So an isotope is a variation of an element with a different atomic mass because it has a different number of neutrons. Remember, if I change neutrons, is that going to change the identity of the atom? Are neutrons in charge of identity? Tell me in the chat box. If I change neutrons, will that change identity? Are neutrons in charge of identity? Are neutrons in charge of identity? Let's go back here. Are neutrons in charge of identity? No! Neutrons have no effect on identity. So if you change neutrons, that will not change the identity. All it's going to do is change the mass. Smiley faces if that makes sense, okay? So carbon with 5 neutrons, carbon with 6 neutrons, carbon with 7 neutrons is still always carbon, okay? So the only thing that matters in terms of identity, again, is the protons, okay? So for example, oxygen, okay, will always have 8 protons. So you can see in my 2 examples here, oxygen, both of these have 8 protons. They both have 8 protons because they're always going to be oxygen, okay? We can see that here. Both 8 protons because they're both oxygen. Oxygen. Okay, now on the other hand though, you can change the neutrons, right? One of these has 8 neutrons, the other one has 10 neutrons. So let's go ahead and actually calculate this. Let's go ahead, add the protons plus the neutrons, that gives us the mass. So for the first one, 8 protons, 8 neutrons, what mass does that give me? 8 protons, 8 neutrons, what mass does that give me? Remember, add them together. 8 protons plus 8 neutrons gives me mass. What does that equal? Everybody in the chat box, 8 plus 8. What's 8 plus 8? Go ahead, put this in here. 8 plus 8. 8 plus 8 equals, yeah, it equals 16. And remember, the units for mass are AMUs. Okay, so Try to make sure you're including units 16 AMUs, atomic mass units, okay? So this means that in order to identify that this is a different type of oxygen, what we do is we just take that mass and we put it after the word oxygen. So this is what we call oxygen 16. Smiley faces if that makes sense. This is oxygen 16 because we know it's oxygen with a mass of 16. Okay, again, the only thing that's changing those neutrons, so therefore it's not anything but oxygen. It's still going to be oxygen. Cool, so now let's change the number of neutrons, right? Let's add 2 more neutrons. Tell me now what is the mass of this oxygen? 8 and 10. 8 protons plus 10 neutrons. 8 plus 10 equals what? 8 plus 10. Try to include those units, please. 8 plus 10 equals... 8 plus 10 equals what? Yes, yes, there we go, Andres. Yes, it's going to give us 18 AMUs. Thank you, Israel. Thank you, Efren. Well, not newtons, AMUs. 18 AMUs. So here we go. The atomic mass for this one is 18 AMUs. But again, it's still oxygen. It still only has 8 protons. Can't change from oxygen. So it's still oxygen, but now it has a different mass. So to identify its oxygen with a different mass, what should I call this? Right? Oxygen with a mass of 16, we called oxygen 16. Oxygen with a mass of 18, we should call what? Tell me in the chat box. Apply what you've learned in the chat box. What would I call this? Put it all together. Make sure you actually answer as a full, right? So oxygen with a mass of 16 is called oxygen 16. Oxygen with a mass of 18 would be called what? The whole thing, please. Reinforce your own learning. I see Efren typing. I see Caleb typing, Noah typing. Yes, make sure you're participating. There we go. Thank you. I see Andres in the chat box. Awesome. There we go. Looks like we're understanding it. Yeah, this one it would be called oxygen 18. Perfect. All right. Give me a, let's see here. Give me a applause sign if you feel like you understand that. Applause sign if you feel like you understand that from your smiley face menu. Excellent. Good, good, good. Just making sure you're awake. Excellent. All right. So again, neutrons don't affect identity. Only protons. So if you change the number of neutrons, there's no effect on identity. That's only the job of protons. So neutrons, no effect on identity. But again, they can change mass because neutrons have mass. So the more neutrons, the more mass. The less neutrons, the less mass. Okay. However, neutrons, what is the charge of a neutron? Positive 1, negative 1, or 0? Tell me in the chat box. What is the charge of a neutron? What is the charge of a neutron? Neutral neutron, what charge does it have? Yeah, it has a charge of 0, right? So even if you change the number of neutrons, that's never going to change the overall charge of the atom because it has no charge, right? So it does change mass, right? Because it weighs or it has a mass of 1 AMU. But it does not change charge because it has 0 charge. Okay, smiley faces if that makes sense. Smiley faces if that makes sense. Okay, so neutrons, no change in identity, yes change in mass, no change in charge. And again, when we change the mass by changing the number of neutrons, we call those isotopes. So for example, protium and deuterium are 2 different ways that we call hydrogen isotopes. So the first one is hydrogen with 1 proton, 0 neutrons. Really quickly, what is the mass of this hydrogen? Hydrogen with 1 proton, 0 neutrons, add those together. 1 plus 0, what's the mass of this hydrogen? Yes, 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 I see Efren, I see Arrow. Yeah, this is just going to be 1 AMU, perfect. So the atomic mass of protium, hydrogen 1 is 1, okay? Deuterium is hydrogen with 1 proton, 1 neutron. What is the mass of that one? What is the mass of that one? Yes, go, go, go. What's 1 plus 1? What is 1 plus 1? Yeah, it's going to be 2 AMUs, okay? So again, the mass can totally change. The mass can totally change, and that is fine when we change neutrons. Okay, so we can see deuterium, hydrogen 2, is heavier than hydrogen 1 or protium. No worries. I totally understand, Noah. Just make sure you grab the ticket and that you have everything you need for anything that you missed, okay? All right, now in the same way, if you change the number of electrons, do electrons have any control over identity? Do electrons have any control over identity? No, there we go. We're feeling more confident about that. Electrons also have no effect on identity, okay? So in this case, though, if you change the number of electrons, remember electrons are so tiny that they have no effect on mass either. Okay, so they do not change mass because they have about a mass of 0 AMUs. However, let's remember electrons, what charge do electrons have? Positive 1, negative 1, or 0? What charge do electrons have? Yeah, they have a negative charge, right? So these have a -1 charge. So if you change the number of electrons, you will end up changing the charge of this atom. Okay, and this is what we call an ion. Anytime we change the number of electrons and it's no longer neutral, right, it's going to be what's called an ion. Exactly, Efren. So you can see down here, we have a sodium atom, which has the same amount of electrons and protons, so it's currently neutral. As soon as it loses an electron, though, it's going to become positively charged, right? Because it's losing negativity, so it becomes more positive. So this is what we call a positive sodium ion. Smiley faces, everyone, if that makes sense. Smiley faces, if that makes sense. Perfect. Oh, sorry, Mr. Alch, I did want to mention the last words are always included in the recording. So that's totally fine that when I know you're talking to Caleb right now, but just as so you know that in the future, all the last words are actually in the recording. Yeah, we do have a ticket. Mr. Alch will be putting those links in the chat box for you, Taylor. So make sure you grab those links and open it up with the password. Okay, so these are called ions, right? Anytime you have a charge on an atom, that's called an ion. Okay, so let's go ahead and take a look at a sodium ion. So a sodium ion is made up of 11 protons, which are positive, and 10 electrons, which are negative. So this is how we would do this. We would take positive 11 from those 11 protons and add that to -10. What does that equal? Tell me in the chat box. What is positive 11 and -10 equal? Tell me in the chat box. Positive 11, -10, what does that equal? Okay, this is not AMUs. It's not mass. So it's just a charge. Charge, we don't really have units for that. So don't worry about the charge here. Yeah, so positive 11, -10, that's actually going to give us positive 1. All right, so this is like saying 11 minus 10, which will give us positive 1. If you're ever confused about that, you can always draw it out, right? So you can draw out a bunch of positives. So here's 5, 6, 7, 8, 9, 10, 11 positives, and then take your 10 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And remember, each positive actually cancels out a negative. So you can actually cross those all out. And whatever you're left over with is your charge. So since I'm left over with a positive charge, I know that this is a positive 1. Smiley faces if that makes sense. So this charge here of the sodium ion is positive 1. Excellent. Now go ahead, let's try this. Let's say we have an oxygen ion with 8 protons and 10 electrons. So this time this would be positive 8. So we got positive 8, and we've got -10. What does that equal? Positive 8, -10. Tell me, what does that equal? Oh, awesome, Ireland. Yeah, this is definitely something that happens in a lot of chemistry classes, so it's good if we're familiar with it. Positive 8 minus 10. Positive 8 minus 10, what does that equal? What charge do I get? What is 8 minus 10? 8 minus 10. Again, if you think of 8 positives, 10 negatives, cancel out. 1 to 1, what are you left over with? Yeah, you're actually left over with a -2. Okay, remember, you actually have more negative here, so this would actually be a -2, not a positive 2. Smiley faces, everyone, if you understand that. So this right here would be a -2 charge. -2 charge. Again, mass does not change because electrons have no effect on mass. Excellent. All right, let's go ahead and start making sure this makes sense. So I'm going to go ahead and give you your whiteboard tools, and I want to know what happens when you change neutrons, what happens when you change electrons, and what happens if you change either of them. Okay, there's something over here that is related to changing both of them doesn't do something. Okay, so go ahead, get your answers up there, use your line tools, work carefully. I know it's a lot of information, so don't worry. I'm sure we'll make mistakes, but we will fix them together and make sure we really understand what's going on. Dorian, if you missed something, you will need to go ahead and watch the recording once it gets uploaded, since we won't have enough time after class to go back to it, since we have another class, okay? All right. Yep, go ahead, take another few moments. I'm going to pause the tools in about 5 seconds. 3, 2, 1. All right. Here we go, everyone. Looking good. Okay, so let's take a look at this. Changing the neutrons, right? We got this. This is called isotopes, right? And we're very confident this changes the mass. Absolutely. Neutrons have mass, so if you change the number of neutrons, you are changing the mass. Changing electrons, we were pretty confident about as well, right? Changing electrons will definitely change the charge because electrons have a negative charge. And anytime we change electrons, changing the charge of the atom overall, that's called an ion. Perfect. Okay, now this one is tricky. Whether or not you change in neutrons or electrons, does that change the identity? Does changing neutrons or changing electrons change the identity of the atom? Tell me in the chat box. Again, do either of these have any control over identity? No. So that means that even if you change both of them, it will always stay the same element. Identity will never change based on neutrons and electrons because the only thing that controls identity is protons. Okay, smiley faces if that makes sense. I know this last one is the toughest one because it just stays the same element. Awesome. This is number 2 in your ticket. Give me a green check when you have it saved. You have 45 seconds. Go, go, go. Waiting on Abelina, Amir, Andres. Green checks, please. Bradley, Bree, Chanel, Donnie, Dree, Dylan, Edwin, Jasmine, Jessica, Caleb, Kyler, TJ, and Whitney. Green checks for number 2. We're moving on in 5 seconds. All right, perfect. Okay, guys, so what I want you guys to remember is that yesterday we took a look at this little square on the periodic table. Do you guys remember that? Right, each of these squares has 2 numbers, one at the top and one at the bottom. Do you remember that? Yes, no? Tell me in the chat box really quickly. Do you remember that from yesterday? There are numbers. Yes, yes, yes. Okay, now the number at the top is our atomic number, which we learned. Atomic number equals protons equals identity. So this makes sense, right? Carbon has 6 protons. It will always have 6 protons. Okay, so that number is important. The other number, though, is the atomic mass. But every time we've talked about atomic mass so far, we've been using whole numbers, right? We've been saying 6 protons plus 6 neutrons equals 12. 6 protons plus 7 neutrons would equal 13. But the thing is, this number on the periodic table is not a perfect number. And the reason this is not a perfect number is because it's actually an average of the different types of isotopes. Okay? So the thing is that carbon can exist in different isotopes. So it can exist as carbon 12, it can exist as carbon 13, or it can exist as carbon 14. Again, protons are always 6, but the neutrons can change, changing the mass. However, when we take the average of all of these, that number is still closest to the isotope that is the most common. So take a look here. The atomic mass of carbon is 12.011. So what do you guys think it's closest to? Carbon 12, carbon 13, or carbon 14? Tell me in the chat box. For the most part, which carbon exists? Which carbon exists the most? Think about 12.011. Is that closest to 12, 13, or 14? Yeah, that number is actually closest to carbon 12, okay? So that makes sense because carbon 12 actually exists naturally. 98.9% of carbon exists as carbon 12. Smiley faces if that makes sense. Okay, so I know it's not a perfect number, but that's because it's actually a weighted average of all of the different types of isotopes that are possible. Okay, and we don't really need to go into that in big detail, but basically you multiply each one by its percentage, add them up together, and that will give you the average atomic mass. Okay, so that's why that is not a perfect number. Good, so at this point we should know a lot about atomic number, we should know a lot about atomic mass. Match these up, let's make sure we understand these. Atomic number versus atomic mass. Go ahead and match those up on the board for me. Match those up on the board for me. Looks like we understand atomic mass. Let's make sure we understand atomic number. Think about mass, right? Which one seems to talk about mass? We're making some mistakes here. Please think carefully. Don't just follow the first person. Atomic number is getting a lot of love there. All right, I'm going to go ahead and pause these tools in about 5 seconds. And this will be number 3 in your ticket. Cool. All right, shrinking these down. All right, atomic mass, we got this one, right? So we got that atomic mass is the sum of adding protons and neutrons together. Good, so that makes sense. Atomic number, we seem to understand pretty easily that atomic number is the number of protons, okay? Now, protons means what? Does protons mean identity or not including in mass? Do protons mean identity or do they mean they're not included in mass? Tell me in chat box. What do protons mean? Yeah, protons mean identity. So these ones are actually the identity. Atomic number means both the identity and the protons. Both the identity and the protons. And that means that left over for atomic mass does not include the mass of electrons, which should hopefully make sense since both of these have the word literally in them of mass. Okay, smiley faces, guys, if you feel good about that. Ethan, you will have to watch the recording when it gets uploaded at 2 o'clock because we're already late for our next class. So we're going to go ahead and have to do that. All right, you guys have 30 seconds. Match these up or take a picture. Give me a green check. And then I'm going to give you your last word. Please work quickly. Go, go, go. Again, take a picture if you need to. We got to move. Awesome. All right, moving on, everyone. Mr. Alch is going to go ahead and send you your quiz links really quickly. Go ahead. Okay, Chanel, I'll go back to that very last one and leave it up there. But anyone else, if you missed something, you'll have to go ahead and go in the recording. Yes, Andres, what's your question? Let's see if I can, here, I can grab these quiz links too. All right, here's our links to our quiz here. There we go. And awesome, here's your last word. Your last word for today is flame. All right, let me know, guys, if you need anything else. I will go back to number 3 and I'll just leave it on number 3, but I'm logging off. I got to go to my next class, all right? Thank you, everyone.